viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Aryabhatta College, University of Delhi. So after the topic of normalization in our previous lectures in this series of database management system, let us begin with a new topic of data storage structures. Now we have seen that a database or a table is actually kind of it is stored as a collection of records. We can say basically we have a file in which there is a sequence of records, and the database is a collection of many such files. So database is stored as the collection of files where each file is a sequence of record. And what kind of sequence of records I am talking about, that we have seen in many of the examples till now. And what actually a record is, so record is a sequence of fields. So after with the collection of fields we are making a record, with the collection of records we are making a file, and with the collection of files we are having a complete database. Now what is the issue, or what are we going to discuss in this particular lecture is how to store these files, how to store these records, what are the different approaches towards the storage of this particular data. Now there can be couple of storage structures, or we can say a couple of methods in order to store these kinds of data. One is we assume, or we have all the records of a fixed particular size, and each file has the records of one particular type only. The other approach which is going to be is variable length records. So first of all, let us try to see what is the first approach, in which we are assuming that all the record size are fixed and having the same, all the records are having the same size, and each file is having a record of one particular type only, and different files are used for different relations. So one relation is kept in one particular file, so obviously all the records will be of the same length because they are belonging to the same relation, and similarly we will be having different files for the different relations. So now if we can see, we are having a fixed length record. So this case is easiest to implement. And what is the assumption? The assumption here is the records are smaller than a disk block. That means the records are actually not we can say spanning onto the various disk blocks. The records are smaller than a disk block, so therefore each disk block is having we can say one record, maybe one complete record or two complete records or something of that sort. So we have a very simple, or we have adopted a very simple approach here, and we will be taking variable length records later. So the simplest approach says we have the fixed length records, and let's say each record is having the size of each record is n bytes. So we will be storing the record I starting from the byte n multiplied by I minus 1, where n is the size of each record. So let us take a very simple example, although hypothetical. Let's say the n is 2 here, so each record is having is taking 2 bytes, and I am talking about the 10th record to be stored. So I minus 1, 10 minus 1, which is 9, 9 multiplied by n is 2 here. So that is going to, the 10th record will start from the 18th byte, and it will be spanning over the other 2 bytes. So it's a very simple calculation. Now the point is, I have just told you that here we need to take the assumption that the records are smaller than the disk block. What will happen if this assumption is not going to hold? Because the records may cross the block. Now how are we going to kind of tackle that particular situation that we need to see? Here in case of this fixed length records, the accessing the records is very simple, because if we are aware of the total size of each record and the number of the record, we can directly jump to the record because by just a kind of simple calculation as I have given with the help of the 10th record, and each record is having 2 bytes. So it will start from 18. So with that simple calculation, your head can you can make your head, the read write head, directly jump to the we can say on a particular location, which on a particular record which we want to access. So accessing the records is very simple because of this whole file having the fixed length records. But the records, if we are not going to take that assumption that records are smaller than a disk block, we may have records which may cross the blocks. So one idea is we should be kind of allowed to have some sort of a little wastage of the records, but we should not allow the records to cross the block boundaries. That means if we can see that one particular record is going to be is going to cross the block boundary, we will shift that whole particular record into the next one. That modification in our storage structure we need to opt for if we want our record access to be simple. Now here if you can see, I have just given a sample snapshot of some records. The record number is starting from 0 and it is going till 11, and it is having some 5 fields. So let us simplify this. It is having some ID number, then the name, then the department of the faculty, and then the salary. This is the old example which we have taken a lot many times, and this is what the structure of the file looks like. So we have seen that in order to make the record access simple, we will not allow these to cross the block boundaries, and insertion or kind of a storage is very simple because we just need to store each and every record in the 2 bytes, then the next 2 bytes, and so on and so forth. What about the another which is very common operation, which is the deletion of record. Now there can be many alternatives to the deletion of records. One is if one particular space is being kind of vacant, is now becoming vacant because of the deletion of the record, we can move record n to the I, that is one particular idea, or we can have another idea in which we will not move the records but link all the free records on the free list. So let us try to explore these two options. So for example, here if we want the record number 3 to be deleted, the record number 3 is having some 22222 as the ID, Einstein is the name, physics is the department, and 95,000 is the salary. And if that particular record is being deleted, we can always shift the record number 11 or the last record to this particular 3, the position which is being vacant, which is being done empty by the deletion of record number 3. But in that situation we need to be careful that while accessing record number 11 we need to jump to that particular location. So that is kind of shifting of records to a particular location. What another approach can be there in case if we don't want to move the records? The next approach says that you need to link all the free records on a free list. So that means we are going to have a linked list data structure to implement this, and this is what is being shown in the figure. So we have one header. So please notice the addition of one record header, which is going to serve as the starting record of the linked list, and that linked list is having all the spaces or all the record spaces which are vacant. So for example, here if you can see in this figure, we have deleted record number 1, we have deleted record number 4, and we have also deleted record number 6. So from header, if we need to go to the first blank space of a record, the linked list is directing head or directing the program to the record number 1. From record number 1, the list says to go to record number 4, and from 4 the list says to go to record number 6. Now please notice that after 6 there is no other record which is being made vacant. So here the linked list is actually ending, and which is being shown by the end sign. So yes, what we have done, that instead of moving those records, because what is happening if we are moving the record n to the I, we need to keep a track of the address of the n which is now being shifted to that particular I. Or another idea is we need to move all the records from I plus 1 to n to I, and that means shifting all the records. That is, if we are going to let's say if we are going to make the record number 3 as vacant, from 4 to 11 we will be shifting all the records. So 4 is shifted to 3, 5 is shifted to 4, 6 is shifted to 5, that means 1 previous to the record. That could be one idea, but that is going to involve a hell lot of movement of data from one particular location to another location, and that is actually a problematic thing. Another idea is just move the record n to I, that we can do, but we cannot do it always, and we also need to keep a track of this changed location. And the third idea says, do not move the records at all, and the link to all the free records is maintained through a free list in the form of the data structure in the form of the linked list data structure. That can be done. So either we will be shifting all the records by one place up, we can say, starting from I plus 1 to n, or we will be moving one particular record in order to fill that space, or we will be maintaining the link to all free records on a free list. All these ideas can be there when we want to delete a particular record, and those records are fixed type. So we have seen insertion is actually not a problem. Access, we can directly go to a particular record, because we have the total number of the total size in bytes for each record, and every record is having the same length. Now coming to the another scenario in which is we can say a bit trickier than the previous one, and the scenario says the length records are variable. So here we have variable length records. Now the question immediately comes up that what is the need of this variable length records, or from where these variable length records arises in the database system. So there can be several ways. Either we are storing multiple record types in a single file. Earlier we have assumed that one particular record type will be stored in one particular file. Now if we are we can say making that constraint liberal, or we are violating that constraint, that means the storage of multiple record types in a file is allowed, and the record types that allow the variable length for one or more fields, such as strings, for example varchar. So in SQL, if you remember, we have seen one particular data type which is varchar, variable character, and this varchar says, let's say if we have given the field size, the type as varchar and size as let's say 50. So 50 is going to be the maximum size for that particular field, and if there is something, let's say a name is being stored which is taking only n bytes, and then 50 minus n bytes are remaining, so the size of that particular file field will be only n, because you have taken variable character. So if we are going to introduce variable character in order to save the space, or in the data type of varchar in order to save the space, this is going to result in the records with variable length. And also we can have some record types that allow repeating fields which are used in some older data models. So what I am trying to establish here is there can be multiple scenarios which are going to give rise to the situation of variable length records. One is storage of multiple record types in a single file, or we can have record types that allow variable lengths for one or more fields, such as varchar strings I have told you, or the record types that allow the repeating field. All any situation is going to give the scenario of the variable length record. Now in order to store this variable length record, we need to store all the attributes in order, and variable length attributes are represented by the size, fixed size, we can say, in terms of offset and length. Offset is something from which a mark or a flag from where you are starting, and length is how much how many bytes it is going to be in length, and with all the actual data stored after all fixed length attributes. So previously what are we going to do here? In case all the fixed length attributes are stored initially, followed by the variable length attributes, and in order to keep a proper track of these variable length attributes, we need to keep this track of the offset and the lengths. And if there are any null values, those null values should be represented by null value bitmaps, as you can see in the screen on the screen. So here we have taken an example. So we have from 0 to 4 bytes we have 21 5, then from 4 to 8 we have some other data, from 12 to 20 we have some 65,000. Then there is a null value which is being represented by a null value bitmap, and after the byte number 21, the new record, or the different fields are being stored, which is having one ID as 101001, then the name of some 10 bytes from 26 to 36, and then some department. So the fixed length attributes are stored in the starting, in the beginning, which is followed by all the variable length attributes. Now when we want to store the variable length records, the page structure is known as the slotted page structure. Now what kind of slotted page structure we are talking about? So block header is there, we are talking about the disk block here, in which there will be the size, that means the number of entries, how many records are being entered. So for example, let's say we have here 4 records, and all these records, if you can see, or if you can notice from the size of the column, all these records are variable length records, because no column is equal. Then after about their location, so we have we have pointers which are pointing from location to the actual records, and also the free space is being maintained separately, which is being used when we have a new record to be stored. The space from this free space section is being allotted to the new record, and this whole page structure in which we are going to store variable length records is known as slotted page structure, and this slotted page header is containing number of record entries, how many number of entries we have. So previously we have seen the example of 4. Then end of free space in the block, we have a free space section, and also the location and size of each record. So if you can see in the figure, all the three the free space, the size and location, and the number of entries are being stored here. And this is what I was telling you, that this is known as the slotted page structure. Now what is the advantage of this slotted page structure is the records can be moved around within a page to keep them continuous with no empty space between them, because we have pointers, we are storing the locations and we can directly go to that particular location. And just what we need to do is to update the entry in the header. The moment we are kind of moving a record, we are storing a new record, the entry in the header is to be updated. That is what is being that is what we need to ensure. But we can keep them in continuous slots with no empty space between them. This is going to we can say save a lot of space. And pointers are actually the pointers which we have seen are actually pointing towards the entry for the record in the header. Instead of pointing directly to the record, they are pointing toward the entry for the record in the header. So this is what you call the slotted, this is what we have seen is the slotted page structure, which is being useful for storing the variable length records. There is no problem in storing the fixed length records, because that's a very simpler approach. But yes, for storing the variable length records, we need a different page structure, which is named as the slotted page structure. Now, other situations in which we need to optimize the store, or which we need to organize the storage very carefully, is when we are storing the large objects. Large objects, we have seen in our previous lectures that blob and clob types are actually large objects which we need to store, and this type of situation also needs the optimization or working on the data storage structure. So how are we going to store these large objects? The alternatives or the solutions could be, we need to store these as files in the file system. That means the types, that is blob and slob types, clob types, will be stored as files in the file systems. Now, when we are talking about the files in the file systems, these are stored as the file which are managed by the database, or we can do we can break into pieces and stored in the multiple tuples in the separate relation. So these are the three alternatives which are available on the screen, if you can see here. So the first is storing of files in the file system. Then we have these files to be managed by the database, and the third thing, we can break them into the pieces and store in multiple tuples in the separate relations. Now we will see that how this organization of records is being maintained in the files in terms of the structure. So there can be various ways. The first one is heap. Heap, as you understand, is actually kind of, we can say, an unorganized memory where the records can be placed anywhere in the file where there is space. Another idea could be sequential, that is to store the records in the sequential order, and in order to access the record, the search key will be very helpful. This storage of records in the sequential order will be based on the value of the search key which is available with the each record. Or we can have multi-table clustering file organization in which the records of several different relations can be stored in the same file, and the motivation or the idea here is the store related records on the same block to minimize input output. So input output time, or the we can say gap time, is going to be minimized, because input output time will be very minimal as the all related records are stored in the same block. Another idea of organization could be B+3 file organization, which is an ordered storage for multiple inserts and multiple deletes. Or another could be, we can have a hash map in which a hash function is computed on the search key, and the result specifies that in which block the file or the record, the record should be placed. So we can have idea of organization or storage as hashing. Then we have B plus tree files, multi-table clustering files organization we can opt for. We can have directly them on the heap, or we can have the sequential access also. So this was actually kind of a glimpse on how are we going to organize the records in the files. And previously in this lecture we have seen the two approaches, which are the fixed length record. We have seen the insertion, deletion and access, and similarly we have seen these operations for the variable length record structure in the form of slotted page also. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. Thank you for a patient hearing.